Right, good evening, rat scum. This is our last lesson of partial fractions. So it's type 4, partial fractions. Okay, and I'm going to refer to these as top heavy partial fractions, that being a good or bad thing depending on you. Okay, and the characteristic, what I mean by that is that you'll have partial fractions now where the degree of the numerator is bigger than or equal to the degree of the denominator. Okay. So, in those kind of questions where the degree of the numerator is bigger than or equal to the degree of the denominator, what you have to do is divide out first. We are going to use what we call a force and balance method. It's my expression, I don't know what it's really called, by inspection, I think. There are lots of different ways you could use long division, daddy, mommy, sister, brother. It's up to you, but I'm going to show you that method. And once you've divided out, then you're going to resolve the remainder into partial fractions using the techniques that you've used before. Right, so get that note down. Right, our first example. X cubed plus 2x squared minus 4x plus 6 over x plus 1. So just your first step now always has to be, is the degree of the numerator bigger than, up to now they haven't been. If the degree of the numerator is bigger than or equal to the degree of the denominator, you've got to divide out first. Okay, so 3 is, the degree of this is 3, the degree of that is 1, so I have to divide. Okay, and the method I'm going to use, as I said, is force and balance. What the hell am I talking about? A force and balance method. So, well, what I do is I say, okay, I'm going to be dividing by x plus 1. What I want to do is I want to force x plus 1 into the numerator. So I just put in the x plus 1. I always do that step first. Then I just look at the first term in the numerator, right? The x cubed. And I say to myself, self, what I have to times x cubed by, what I have to times x by to get back to x cubed. Okay? And I have to times x squared by x. So I just look at the first term. So what did I do again? I force in the x plus 1, and I just look at the first term. And I say, what I have to times x by to get back to the first term by x squared. So that is what we call, this is a forcing part of the question. Okay. Now I've got to balance it out. What do I mean by that? Well, if I times this back out, okay, I'm going to get x cubed, okay, plus x squared. X squared times what is x squared? But what was in the numerator? Okay, 2x squared was there. So now I've got 1x squared. So now I've got to balance it out. What I have to do to 1x squared to get back to 2x squared, I have to add another x squared. So that's what I mean by the balancing part of this. Okay, because I'm just rewriting this numerator. Okay, I can't change the value of it. It's got to still be the same as that, but just in a different form. So I've got x cubed, which is right, plus x squared. Now I've balanced it with another x squared, so x squared plus x squared is 2x squared, so now it's balanced. Okay, and I've still got to bring down that minus 4x plus 6. Okay, right, so now, well, if I gave you this 14 over, I don't know, 14 plus 21 over 7. Okay, we could write that as 14 over 7 plus 21 over 7, which would be 2 plus 3, which would be 5, right? Okay, so you can split that up, okay, if it's over a single term. So I could go, I'm normally not going to write this step down over here, okay, I'm just going to do it by inspection. But I could say, using this logic over here, that I could rewrite this as x squared x plus 1 over x plus 1. Okay, so that bit over there. Okay, plus what's left, x squared minus 4x plus 6. Just put that down. Okay, over x plus 1. Okay, it's just using this logic over here. Okay, it's over a single term, you can split it up. Right, now it becomes obvious that the x plus 1s are going to cancel. So you're going to have x squared. Again, you can, with practice, you'll start to skip out steps. So you're going to have x squared plus x squared minus 4x plus 6 over x plus 1. Okay, so normally you're going to skip out the step and go straight to here. You're just going to say, okay, well, I'm not cross cancelling, be careful. If I divide that by that, I'm just left with x squared, but I've still got to go and divide that by that. So normally, as I say, we'd go straight to that over there. Right, okay, focus, okay, now concentrate, okay. Right, so now, okay, but x squared minus 4x plus 6 over x plus 1, okay, and I'm not finished, because I can still do further division. As long as the degree of the numerator is bigger than or equal to the denominator, I've got to carry on dividing. So I'm going to repeat this process again and again and again. So what's my process? Well, don't forget to bring down the x squared, that hasn't changed, plus something over x plus 1, and now I've got to do the forcing part of this division. So the forcing part is I force x plus 1 into the numerator. Okay? Now I say, right, what I have to look at the first term over there, what I have times x by to get back to x squared, well, I've got to times it by x. Right? So that's the forcing bit. Okay? If I times this back out, I get x squared plus x. The moment I'm sitting on 1x, but I should end up at negative 4x. So what I have to do to 1x to get to negative 4x, I have to take away 5x. Just check it. Remember, this line should be the same as that line when I times it out. I get x squared plus x. X minus 5x is minus 4x. I've done balancing over there. Don't forget, though, you still got to bring down the 6. Okay? Right. So now, using this logic over here again, I'm going to say, right, x plus 1 over x plus 1 is just going to leave me with x. So I've got x squared. When I divide that out, I get x. Okay? Plus, I've still got this bit over here, minus 5x plus 6 over x plus 1. Okay? Now, that degree is the same as that, so I'm still not done. Okay? I've got to divide out again. I'm going to divide out again using that force and balance logic. So I'm going to have x squared plus x plus, put the x plus 1 there. What do you have to do now? You have to force the x plus 1 into the question, into the numerator. So I force in the x plus 1. Then I just look at the first term up there, which is negative 5x. Okay? So what I have times x bar to get to negative 5x? Well, by negative 5x. Now that's the forcing part. Now I've got to balance. Minus 5x is obviously fine. Minus 5 times 1 is minus 5, but I've got to get to plus 6. Okay? How do I get, if I'm at minus 5 and I want to get to plus 6, okay? My 6s are terrible. Okay. I've got to add minus 5 plus 11 will give me 6. If I times it back out, I get minus 5x, which is right. Minus 5 plus 11 is 6. Right. So I'm just, and that means I end up with x squared plus x. If I divide that out, I'm left with negative 5 plus 11 over x plus 1. Right, now that's the remainder, 11 over x plus 1. And that's, I can't do anything with that. Okay, it's resolved already into partial fractions. You can't do any more with it. So that just is your final answer. Often over here we're going to have more work to do, okay, because we've got to split the remainder, that's the remainder, up into its partial fractions. Okay, so the whole thing is just forcing and balance. You keep doing this until you end up with that degree less than that degree, and then you've done the division part of the sum. In this case, we've done the whole sum. Right, get that down. Rosa, 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 I hope you're with us. Right, and hello. Right. The next one. Okay, resolve this into its partial fractions. Well, your first thing you're going to do is check, is it top heavy? Well, the degree of the numerator is bigger than the degree of the denominator. So straight away, you know you've got to divide out. First, how are we going to divide? By using forcing and balancing. And I'm going to start skipping little steps now. So I've got something over x squared plus x minus 2. Right. So my first thing is I've got to do the forcing. I've got to force that into the numerator. So I just do that. X squared plus x minus 2. I force it in there. Okay? Right. Then, just look at the first term here. What I have to times x squared by to get to 2x cubed? Okay? Well, 2x, this is the forcing part of it, times x squared will give you 2x cubed. Now I've got to do the balancing part of this method. So 2x times x is 2x squared. But what's up here? It's positive 5x squared. Okay. So what I have to times, I've got 2x squared. Okay. To get to 5x squared, I've got to add 3x squared. Right? Just give me 1 sec. Okay. So, we said we've got 2x squared, we've got to get to 5x squared, so to balance it, okay, I balance it with that 3x squared over 9. Now, there's still more balancing to do. 2x times negative 2, but times that out, I'm sitting on negative 4x. But what do the x's have to be? Negative 1x. So what I have to do to negative 4x to get to negative 1x, I have to add 3x. So check. Okay. If you times this back out, you get 2x cubed. Plus 2x squared plus another 3x squared is plus 5x squared. Minus 4x plus 3x is minus x. Okay, so we balanced it. Okay, so all of this whole bit over here, that was the balancing part of the method. Okay, I balanced the x, don't forget I still got this minus 3 to bring down. Okay, check that that makes sense to you. Right, now I use this logic. I can split the sum up into that divided by that plus that whole thing divided by that. When I divide that out, I'm left with just 2x, right? So I've got 2x, that's that divided by that. Okay, but I've still got, I'm not cross cancelling, I've still got to have 3x squared plus 3x minus 3 over x squared plus x minus 2. Well, those degrees are the same, so that means I've got more division to do. Right, so go try to do the forcing and balancing bit of that. Off you go. Right, so if I do that, I've got 2x plus, now what I'm going to do, I'm going to force x squared plus x minus 2 into the numerator. Then I'm going to just look at the first term. What I have to times x squared by to get 3x squared? Well, by 3 obviously. So now I've got 3 times x squared, which is balanced. And I've got plus 3x, which is good news because that's also balanced. Okay? And then I've got minus 6. But I have to end up with minus 3 over there. So at the moment I'm sitting on minus 6. To get to minus 3, to balance the constants, I've got to add 3. Right? All over x squared plus x minus 2. Okay, so I've got that divided by that plus that divided by that. That cancels and I'm left with 2x plus 3. Okay, plus 3 over x squared plus x minus 2. Okay, and that brings the division part of the question to an end because now the degree of the numerator is less than the degree of the denominator. But, okay, so I'm sitting at, it's been resolved so far into 2x plus 3 over x squared plus x minus 2. And that's the remainder. Okay? And that remainder hasn't been resolved into its partial fractions. So we're going to try to resolve this into its partial fractions. I'm not yet finished, in other words. Okay, so sometimes you can, usually 99% of the time you're going to have division, and then you're going to have to resolve the remainder into its partial fractions as well. Right, so I want you to now just look at the remainder, which is 3 over x squared plus x minus 2. Right, and you should be able to manage to do that yourself. Go resolve this into its partial fractions. Off you go. Right, so if I resolve that into its partial fractions, it becomes 3 over x plus 2x minus 1. Okay, and it's just two linears, so I can rewrite that as a over x plus 2 plus b over x minus 1. Okay? Focus. Okay? Plus b over x minus 1. Right. What I do now, okay, right, I'm going to get rid of the denominator. Okay, and I'm going to get rid of the denominator. What am I actually doing? I'm timesing by the LCD. So, Carla, what are you going to get? Good. You're going to get 3 is equal to a x minus 1 plus b x plus 2. So, Isara, suggestions, good. We're going to sub in now x is equal to 1, because if I sub in x is equal to 1, it will eliminate that term, and I'm end up with 3 is equal to b, replace x with 1, 1 plus 2, so therefore 3 is equal to 3b, okay, so therefore b is equal to 1, right? I've still got to find a, which is going to be easy. How are you going to do that, Sarah? Good. Sub in x is equal to negative 2. And if I sub in x is equal to negative 2, I get 3 is equal to a negative 2 minus 1. Remember, I'm subbing everything into there. Okay, I subbed in 1 into there, and I subbed in negative 2 into there. And I get 3 is equal to a minus 2 minus 1. If x is negative 2, that disappears. So I get 3 is equal to negative 3a. Divide by negative 3, and I get 1 is equal, a is equal to negative 1. So I've got a is negative 1, and b is 1. So in other words, this remainder would be negative 1 over x plus 2 plus 1 over x minus 1. Okay, that's just the remainder though. So 3 over x squared plus x minus 2 can be resolved into that. You really need to write the final answer down. So your final answer, okay, is that this whole thing over here, I'm going to call that star, okay, resolves into what? Well, it resolves into, you've still got this 2x plus 3, so star is equal to 2x plus 3, okay, then the 3 over x squared plus x minus 2 resolved into plus, the plus sign there, negative 1 over x plus 2, okay, plus 1 over x minus 1, and we should really make it a bit prettier, which is equal to 2x plus 3 minus 1 over x plus 2 plus 1 over x minus 1. Okay, quite a lot of nice algebra going on there. Check that makes sense. And get it down. We're getting there. Right, carrying on. Right, you've got 3x cubed plus 12x squared plus 1 over x squared plus 4x plus 4. Right. The degree of the numerator, it's top heavy, is bigger than the degree of the denominator. Okay, so I want you to all go try do the division by that method we've been talking about, force and balance. Right, off you go. Give the division a try. So, for forcing and balancing, we've got something over x squared plus 4x plus 4. Okay, so I've got to force x squared plus 4x plus 4 into the numerator. Okay, I look at 3x cubed. Okay, to get 3x cubed, what I have to times x squared by 3x. Okay, that's the forcing part of things. Okay, if I times this back out, I get 3x cubed, but now I get 12x squared. Oh, great, that's also balanced, because 3x times 4x gives me 12x squared. Okay, and then I'm going to get 12x. Okay, but were there any x's in the numerator? Okay, there are not any x's in the numerator. So I'm sitting on 12x, but I've got to get back to 0x, in other words 0. So I've got to minus 12x, because then I'll have 3x cubed plus 12x squared plus 12x minus 12x balances, because there are no x's there. Okay, and then I've still got to bring down that one. Check that makes sense. Righty then, okay, now I can split it up into that part and that part. That divided by that leaves me with just 3x. So I've got 3x plus, and then I've got negative 12x plus 1. Okay, plus negative 12x plus 1 over x squared plus 4x plus 4. Okay, so plus negative 12x plus 1 over x squared plus 4x plus 4. So, I can't divide anymore because that degree is less than that. Okay, so I've got to just look at this part over here, which is the remainder, and I've got to go and resolve the remainder into partial fractions. In other words, I've got to resolve minus 12 over x squared plus 4x plus 4 into its partial fractions. exhausted. Go try to do that. Give that a go. Minus 12 over x squared plus 4x plus 4. Okay. So if I resolve that, well, what does it factorize to? X plus 2 all squared. And now you've got to be careful of that type because there's a hidden linear factor in there. So we can split that as a over x plus 2 plus b over x plus 2 squared. Check your work. Okay, go finish it off. Okay, and so what am I going to do here? Okay, Ishani, good. I'm going to times by x plus 2 squared, and I get negative 12 is equal to a. I'm missing an x plus 2 there, plus b. So now, remember, I'm only really working with this part of the sum. That's a b, not a 13. I do apologize. It's a funny looking b. Okay, and now you've got to solve for a and b. Well, the easiest way to do it, okay, is if you let x be equal to negative 2. And if I let x be equal to negative 2, okay, neighbor, what are you going to get? You're going to get minus 12 is equal to a. Negative 2 plus 2, that disappears. So I simply get b is equal to minus 12. Okay. And then to go find a, well, to find a, I can simply look at the x's because I've got minus 12 is equal to ax plus 2a plus b. You can skip out steps. If I equate the coefficients of x, okay, well, there's no x's there. So I've got 0x, okay, is equal to, no, that's not what I'm on. Pause. The tightness does. Okay. So I've got x is equal to minus 2, so b is equal to negative 12. Now I've got to solve. Okay. So b is negative 12. Okay. Pause. Right, hopefully you've all been squealing like sick pigs because I've made a complete mess up. Okay, the remainder was minus 12x plus 1. Why didn't you say anything? With x squared plus 4x plus 4. Any more mistakes on the push-ups? So it becomes minus 12, let's just race through this. X plus 1 over x squared plus 4x plus 4 is x plus 2 all squared. Right? Which is going to be equal to a over x plus 2. Okay? Plus b over x plus 2 squared. Right? Okay. Multiply everything out by x plus 2 squared, and I get negative 12x plus 1 is equal to a x plus 2 plus b. Right? So now I'm going to look at this part of the sum. Okay, if I look at that part of the sum over there, okay, well, I eliminate by subbing in x is equal to negative 2. So negative 12 times negative 2 plus 1, that'll disappear, is equal to b. So therefore, 25 is equal to b. Okay, that's it, x is equal to negative 2. Okay, so now I've got b is equal to, I'm just going to here, I'm going to change that into 25. Okay, and if I look at the x's, coefficient of x's, okay, I have minus 12x on the left, must be equal to ax on the right, it's equating coefficients, so I get minus 12 is equal to a. Okay, that's all correct. Okay, and so in other words, this whole sum over here, and call that star, is equal to, well, don't forget you've got the 3x, so 3x plus, now negative 12x plus 1 over x squared plus 4x plus 4 became a over x plus 2, which will be plus negative 12 over x plus 2 plus b, which is 25 over x plus 2 all squared. Okay, and then a plus and a minus, you can simply rewrite that as 3x minus 12 over x plus 2 plus 25 over x plus 2 all squared. Oh, okay, get that down. Okay. Last example, thank the Pope. Right, I'm exhausted, I'm tired, lockdown's about to kick in. I'm probably going to get booted out the house and have nowhere to stay for lockdown because I'm so late. But let's get this out the way. No mistakes, otherwise push-ups, let's go. Right, so stop heavy, go do your division, off you go, try it. Okay. Right, so if I divide out, I'm going to have x cubed minus 1. I want to force x cubed minus 1 into the numerator. Okay, then I look at the x4, what I times that by? So x times x cubed will give me x4. Now I unbalance the equation by doing that, so I've got to balance it. So at the moment I'm sitting on negative x, but there are no x's, so I've got to go and add x. Okay, so I get x to the 4 minus x plus x balances, and I've still got that 1 which you've got to carry down. Right? Go simplify that and carry on. So now I get, that cancels out, not cancels, it's divided out. So I get x plus 1 over x cubed minus 1. Is there any more division to do? That's right, no there's not. Okay, so now I've got to resolve this into, it's a remainder into partial fractions. So let's go to that part over there. So I've got x plus 1 over x cubed minus 1. Go resolve that into its partial fractions, off you go, be good. Okay, well, I've first got to factorize that, it's a perfect cube, so it becomes x minus 1, x squared, times them together, change the sign, square the last one, and I get x squared plus x plus 1. Right, so I've got x plus 1 over x minus 1, x squared plus x plus 1, and I've got to go and resolve that into its partial fractions. Right, well x squared plus x plus 1 can't be factorized. Okay, so I'm going to write that as a, it's an x by the way, okay, a over x minus 1, the linear. Then I've got an irreducible quadratic, so it's going to be plus bx plus c over x squared plus x plus 1. Okay, what I do now, multiply by the denominator, so I'm going to get x plus 1 is equal to a x squared plus x plus 1 plus bx plus c times by x minus 1. Right, so now I'm only going to be working with that part of the sum. Okay, and I'm going to solve for a and for b and for c. Off you go, give it a go. Right, so I'm going to let x be equal to 1, because that will eliminate. So I get 1 plus 1 on this side, and here I get a 1 plus 1 plus 1. That disappears. So I get 2 is equal to 3a. So therefore, 2 over 3 is equal to a. Okay, so a is equal to 2 over 3. Okay, next one, I've still got to find b and c. So to find b and c, well, I've got a is 2 over 3. So I'm going to rewrite that box over there, and I get x plus 1 is equal to 2 over 3 x squared. I've replaced a with 2 over 3. Then I'm timesing 2 over 3 out into that bracket. So I get 2 over 3x squared, okay, plus 2 over 3x plus 2 over 3. If I times this out, I get bx squared, okay, minus bx plus cx minus c. Hopefully there will be no deliberate errors here. Bx squared minus bx plus cx minus c, that looks right. 2 over 3x squared plus 2 over 3x plus 2 over 3 is equal to x plus 1. Right. Okay, you don't have to times out, you can just do it by inspection. Okay, but I have to solve it times out. Right, now we're going to solve for b. Okay, well there's a b, which involves x squared, so I could use the x's. Where the other x squareds, there's the x squared, there's no x squared on the left hand side. So if I equate coefficients of x squared, I've got no x squareds over there. And it must be equal to 2 over 3x squared on the right, plus bx squared. So I've got 0 is equal to 2 over 3, must be equal to 2 over 3 plus b. So negative 2 over 3 is equal to b. Check that. So b is equal to negative 2 over 3. And I've still got to find b, I've still got to find c. So we're looking at this equation over here. And where's c? Well, c's there with the x's, we can use that. Okay, or I can just use the constants. Okay, there's a c over there. Okay, so if I look at the constants, I get 1 on the left-hand side must be equal to, there's another constant over there, there's a constant, here's a constant, and there's a constant. Okay, so 1 is equal to 2 over 3 minus c, so therefore c is equal to 2 over 3 minus 1, so c is equal to negative a third. Right, so I've got C is negative a third, I've got B is negative 2 over 3, and I've got A is equal to 2 over 3. Right, so go write down your final answer. Okay. I'm just going to get rid of that other rubbish. Right, so what I've worked out, okay, is that this, remember this is just the remainder, okay, what the hell is the one? X plus 1, sorry, we had x, so we had, this was the whole sum, x plus 1 over x cubed minus 1 became that, okay, and this resolves into a is equal to, what was a? I wrote it out. Okay, a was equal to 2 over 3. Yep. Okay, so I'm going to have 2 over 3, that's a, okay, over x minus 1, plus, what is b? b is negative 2 over 3 x plus c, which is minus, c is negative 1 over 3, so it's going to become plus and a minus makes a minus 1 over 3 x squared plus x plus 1. But that is viciously ugly, and we can neaten it up to 2 over 3 x minus 1, because that can go to the bottom. Here I can take out negative a third, so it'll be minus, I'm going to put the negative 1 over 3, and now we have to have the 1, x squared plus x plus 1, so it's going to be minus, okay, and if I take out a negative, that'll become positive x, okay, positive 2x, and this will be plus 1. So that's just the remainder, the whole thing, in other words. Remember there was that x in the beginning, so that x4 plus 1 over x cubed minus 1 resolves into that x, and then x plus 1 over x cubed minus 1 became that, and that resolved into this whole thing over here, so it'll be equal to x plus 2 over 3 x minus 1 minus 2x plus 1 over 3 x squared plus x plus 1. Right, we're done. Right, grab bags. All that's left to say is that I want you to do exercise 2.4 in your Evans thing, the memos are on Teams. Okay, so the work for your test is finished. Okay, see Teams for the revision. That will help you out, and good luck with everything. Stay safe. Arrivederci.